My name is James Coughlan. I'm a senior scientist here at Smith-Kettlewell, and I'm also the director of the Rehabilitation Engineering Research Center, or RERC, on blindness and low vision. And my background is physics, but as soon as I began working at Smith-Kettlewell, I was already doing computer vision and decided that this was a great place to apply computer vision to the needs of people who are blind and low vision. So it's what used to be called assistive technology and now is often called accessible tools. Accessibility is the general term. I like to sum up what I do as making computer vision based accessibility tools, particularly that help people understand the physical environment, exemplified by things like maps. You have a tactile map that you can feel, but if you don't have vision, you can't see the labels on it. I have a lot of experience with finding fruitful overlap. So on the one hand, you have AI, which is very useful in some ways, but still often surprises us all in how it may be limited. You have these very powerful tools that can give you information about the environment, but the tools are imperfect. And then the other thing is that suppose you have all the information about the scene. How do you convey this in a helpful way to a user? So user interface design and testing user interfaces, that's something that is also really important that I focused on. And in the past, I think far too many engineers saw a tool and thought, oh, there must be a really great way to use this. Let's extract this information from the environment and just blast it at the user. A lot of people who are new to the field assume that blind people want to have a lot more guidance as they're walking to avoid obstacles or drop off stairs going down hazards, right? And there is some interest in that. I'm not trying to diminish that. But in general, people who are blind who take orientation and mobility training, the mobility part is all about learning how to stay safe while you're walking. So if you're using the cane, you're constantly sweeping the environment and you will pick up a stone on the ground, or you'll sense that there's a staircase. And that's the way that they stay safe. And I'm not proposing technology that's going to eliminate the cane. I'm trying to help people with a problem that is much more pressing. Okay, if I know how to use a cane or I have a guide dog who can lead me safely, I don't want to have to wander around this new building too long because I don't know where anything is. I can't find the signs, I can't read them. So connecting the needs of blind people and low vision people with the capabilities that are available, I think is sort of my specialty. Using computer vision, we have a project we call CAMIO, which will allow you to get audio labels about sites of interest on an object. So for instance, if you have a relief map and there's a mountaintop, if the camera from, let's say, a smartphone mounted above this relief map, if it sees that the user is pointing at the mountain peak, it can just say the name of the mountain peak, like Mount McKinley. And the idea is that it promotes multimodality because the blind person, at a minimum, has tactile access and understands the shape of things. And in it, for instance, a tactile map, which is flat, streets will be represented by raised lines. And so they have an idea of the geometry of the streets. And by adding audio labels, you can then point at a street and get the name read aloud. This is an example of an application of the CAMIO. CAMIO is the project I mentioned before. It stands for Camera Input Output. And the overall idea of CAMIO is that you have some object. It could be a flat tactile map, or it could be, like in this case, a three-dimensional model. And it provides audio feedback. So the person who's exploring the map can point somewhere and get audio feedback. This is called the Magic Map. It's a scale model of an actual playground called the Magical Bridge Playground in Palo Alto, California. So this is designed to allow a person to explore. A very typical way to explore a three-dimensional or tactile map would be just to move your hands and all over and see what's there. Let's try that now.
Cozy cocoon and spinning zone. Climbing giraffe. The climbing giraffe is a four-sided structure in the talk zone with many fun things to do. On one side is a 4-foot-high giraffe whose long neck bends down to the ground, forming an archway to move under or climb on.
Universal design aspect is not just about accessibility. That's been historically my main motivation. You can make models that are aesthetically beautiful to sighted people, and adding the Cameo component can make them very informative. People would enjoy visiting the reception area of a company, finding a visually stunning model, And if you tap on it, you hear something about it. That's a really great way to engage with what's in this building. It doesn't replace talking to people and asking questions, for instance, a receptionist, where can I find such and such? But it really invites people to explore the building map in a way that is new and fun. If you have vision or not vision, it's a nice way to interface with this information. This project has been ongoing, and we're always looking for new opportunities to do new installations. And so there may be people in industry who would like to get involved. Perhaps you have a public facing building on a tech campus and you'd like to welcome people. And maybe you want to have some sort of three-dimensional map. It could be of the campus, it could be maybe the particular floor of the building that the person is currently on. And if you want to make this map fully accessible, then something like CAMIO would be a really good approach. And so I invite people from industry to get in touch with me if they'd like to pursue these kinds of ideas. If someone is in a company and they're very interested in AI and they think about ideas, oh, this AI function or capability might be useful for blind people or low vision people, I would be very happy to talk to, because I've worked with a lot of blind people, but more than that, I've also worked with teachers of the visually impaired, and they will be able to represent the needs of not just one or two people, but literally hundreds. And they can speak to me. I talk to them on an ongoing basis, and I have an idea of what are pressing problems, and not just that, but what kinds of solutions are going to work.